you're going to run into these things called Bessel functions, and I've really totally forgotten what they were for, but they're infinite series. And it looks terrible, but we have a theorem that says that we want to find the derivative of this. We can do this term by term. Now, personally, I don't want to even write it out term by term. Because the only thing I have to differentiate is that. Because when I take the derivative of both sides with respect to x, I can pull that operator through all that summation. And all I have to differentiate is this. Because does the derivative affect the ends? No. The derivative only affects what letter? X. So it's -1 to the n. You could write it out term by term. I don't want to do that because that looks like too much work. Times the derivative with respect to x of x to the 2n. And this is the big theorem in this section. Yes? Formative. And we'll do that Wednesday. Okay, so that's not so bad. Kevin, what's the answer to this?
It's going to be 2, it's going to be...
We just ignore all this. I don't care if you reduce.
2x to the 2n.
So it's, no, what do you do with the exponent? It's a power. It's 2n times x to the what? 2n minus 1. And I'm done. Don't make it hard. If I wanted to integrate it, I would also do the same thing. Well, that's what we're going to do. We're going to generate some other power series by looking at derivatives and antiderivatives of known power series. But that still isn't going to give us everything. That's going to give us the whole family of the geometric one. Because you remember that what is 1 over 1 minus x? Remember what that one was? It was 1 plus x squared plus x cubed plus x to the m. Remember that? And we had families of this. We also did things like x over 1 minus x, if you did the homework. So that's x times 1 over 1 minus x. So you just take this series we already have and multiply it by x. Does that make sense? If it doesn't, maybe you didn't do the homework. Because we did that in the homework. So this would be x times this thing, 1 plus x squared plus x cubed plus, and that's x to the n. Okay, I could write that in summation. I'm not particularly concerned about it. So we're going to do some more things. Are you ready? We did that before, right? Okay. I want to get 1 over 1 minus x squared. And there's a relationship between, in terms of calculus, between this and this one. What's the only thing? Just so you can see that you can take the derivative right inside. It's all you have to do. The derivative doesn't affect the x's. And it's just a real example of where you use it in physics with the Bessel functions. And there's tables and stuff. You just look things up. Now, what's calculus involve? Derivatives and antiderivatives, right? How is this related to this one? What if you took the derivative of 1 over 1 minus x? Well, I'm not even going to do it that way. I'm going to use the power rule. And I'm going to make this 1 minus x to the -1, because that's easier. You can use quotient rule. Okay, what do you get?
Oh, it's the integral.
-1 times 1 minus x to the what? -2 times -1. So the derivative with respect to x of 1 over 1 minus x is equal to 1 over 1 minus x quantity squared. So that tells you what you have to do. Mm-hmm. That far enough or more? I think this is kind of cool. So I want to get some more power series by differentiating and integrating the one I know. And then you're going to combine them all. You're going to see them on the multiple choice part of the test. I don't like that look. I was like, oh no. So you have to recognize what it is. And that is not always easy. Okay, so are you ready? I'm going to go to my next slide because that's where I have it. Well, the derivative of this is equal to that. So let me go to this one. Oh, it helps us a lot. I want to find this. 1 over 1 minus x squared is the derivative of 1 over 1 minus x. Do you guys agree that that's true? Okay, we know the power series for 1 over 1 minus x. It's one we must memorize. That's 4. So it's the derivative of, well, that's just 1 plus x squared plus x cubed plus x to the n plus, and what's the, I can do the derivative of that, can't I? That's easy. It's just the power rule. It's the reason why we write them as powers. So your calculator does too, by the way. It doesn't do 1 over 1 minus x squared. It uses the power, the infinite series, because it converges very quickly. So, David, what's the derivative of this one? Yeah, what's the derivative of 1? Plus 2x, 3x squared, and the nth term is n x to the n minus 1. So now you have the power series for 1 over 1 minus x squared. Now it's related. It's the sine of x related to 1 over 1 minus x. Is there anything you can do to this to make it look like 1 over 1 minus x, the sine function? What are you going to do with it? I don't know what to do with it. If I integrate sine, I get cosine, right? Negative cosine. There is no relationship there. What about e to the x? There's no relationship there to the geometric form. These are only the families of the geometric series. Only, and we're talking about maybe a distant cousin or something here. Families of the geometric series. And there's a lot of things we can do. What happens if we were to integrate, sorry, what if I integrate 1 over 1 minus x dx? Because we know what 1 over 1 minus x is. Hey, Kevin, what if I integrate that? Do we want to do a u substitution? Or?
We want to do u substitution.
Okay, so what's u equal to?
U is going to be 1 minus x.
Then what's du, Matt?
Negative 1.
Negative 1 times dx. So that's equal to the integral of 1 over u du with a what? Negative sign. And what's the antiderivative of that?
Absolute value.
Plus c. You have to put the c's in. Okay, Kevin? That's good. So the integral, guys, is equal to negative log of the absolute value of 1 minus x. What's true here? Can I find the power series for the log of 1 minus x? It's the antiderivative, I forgot my dx, of this power series. Well, that's what we're going to be doing in this section. That's why you need to do it with me. If you integrate 1 over 1 minus x, you get negative log of absolute value of 1 minus x. So can I get the power series for that? Can I integrate that? Well, I haven't integrated, but can I? Can I integrate this power series?
Yes.
I think that's on, is it on over here? Okay, so let's start here. Negative log of 1 minus x is equal to the antiderivative of 1 over 1 minus x. We'll put the c in a moment. Does it matter which side I put the c in?
No.
Not really. No. Okay, just let's solve this. The log of 1 minus x is equal to the integral of 1 over 1 minus x dx with a negative sign out in front. Do you agree? We got rid of the absolute value. We'll keep that positive. So we're going to say that x is less than 1. Is that okay? We know x is less than 1. Remember what the rate of convergence is? Geometric series. The absolute value of x is less than 1. So I'm okay. Now, let's do this. It's minus the integral of, and what is that series? It's a geometric one, 1 plus x squared plus x cubed plus x to the n plus, okay, do you guys agree? And that's the log of 1 minus x. So what's the log of 1 minus x? What's the antiderivative of 1? X plus, what's the antiderivative of x? X squared over 2 plus, oh, I have a negative out in front. Okay, plus x cubed over 3. What's the antiderivative of x to the n? N plus 1. It's not that hard if you just think for a moment. Memorizing, yeah, it's hard. And then what do I have to put at the end of this? Plus c. And you know what? We can find out what c is. I can put any x value I want, but I prefer to have my x's between 1 and negative 1. What's the easiest x value I could put in there? I can put anything I want. If I put 0 in, if x is equal to 0, I'm going to put this in here. So it's the log of 1 minus 0 equals, what's going to happen to all these terms if I put in x equal to 0? 0 plus my constant. So c is the log of 1, but we know what the log of 1 is. It's 0. It's not always 0, but it is in this case. In this case, it does not always 0. No, you're not hearing me. If I do a different function, c is not always 0. Just not in this case for this particular function. Well, let's try some more. This is what the homework is like. I want to find the power series for the inverse tangent. Can you believe that? That is related to the geometric one. What? No, I wouldn't do integral. Well, I may have to do integral. I can't integrate inverse tangent. So what I do is this. The derivative, do you remember this one? Okay, guys? The derivative of inverse tangent is what? David, do you need to sit someplace else? You're really distracted by those guys. 1 over 1 plus x squared, right? So how would I find the inverse tangent? You were right. How would I find inverse tangent? If the derivative of inverse tangent is this, then how would I find inverse tangent? What would you do to both sides? Integrate it, right? So the inverse tangent of x is equal to the antiderivative of 1 over 1 plus x squared dx. Remember how we found that one? Well, we have to know this power series. But we know this power series because we know this. 1 over 1 minus x is 1 plus x squared and x to the n. Right? How do I get, if you haven't done the homework, then maybe you don't know. How do I get 1 over 1 plus x squared to look like that? It's 1 over 1 minus what? A negative x squared. Remember doing that? We did it in this class. And so I'm going to put a negative x negative x squared right there. So it's 1 minus x squared plus x to the 4th minus x to the 6th plus, and it's minus x squared to the n. I think if I'm going to integrate it, I'm going to have to simplify that. I don't really think I have a choice now. This is easy to do. I can easily integrate the power series. I just do it term by term. That's all. So inverse tangent of x is equal to the integral of this power series. 1 minus x squared plus x to the 4th minus x to the 6th. Now, I want to get an alternating series. So it's going to be what? That's minus 1 to the, I need to simplify that. Minus 1 to the what? N. Actually, is it N? Or is it 2N? It's going to be 2N, isn't it? Because it's, no, it's N. I just follow the algebra, it's N. It doesn't have to be, I don't want it to be even because it does have to alternate, so it has to be both of those. And then this is x to the 2n. Okay, so let's integrate that. This is what the homework looks like. This is homework that's really important for you to do. And it unfortunately always happens at this time of the year. What's the antiderivative of 1? X minus x cubed over 3 plus x to the 5th over 5 minus 1 to the n will not be affected. Still an alternating sign. And this is x, x to the what? 2n plus 1 over 2n plus 1 plus c. Now x is going to be between 1 and negative 1. No, because it was geometric. It's geometric. Well, you have to recognize, and you know there's only so many in the family, so after you've done them all, you should recognize them. It's a big family. But I still can't figure out how to get sine, cosine, regular tangent, e to the x to do this. So we're going to have to find another method, and we'll do that after winter break. We'll come back, and we'll find out a way that works no matter what function you have. This is only the family, the geometric family. And I need to find c. So what's the easiest value between 1 and negative 1 you can put in there? You could put 1 in there, but I don't know what that adds up to. X equals 0, so I have inverse tangent of 0. Well, what happens to all these guys? They're all what? 0 plus c. It turns out inverse tangent of 0 is also 0, so c is 0. Okay, and that's it. That's the inverse tangent.
So when they write, I was going to find the power series representation. Does that like write the whole x?
This is the power series representation right here. You may use it in summation notation. Some of you will. There's always somebody who says, you know what's easier just to do it in summation. Then I have to write all those terms out. And you're right. These are all power series. A power series is a series, which means we add numbers up, and these are all powers. Not exponentials, they're powers. That's a question? Question? Okay. Sure. Let's try the last one. These are power series representations. Because you know what? If I want to integrate x times inverse tangent of x, we don't know how to do that. Do we? But we can. If we were to multiply x times inverse tangent of x, you're going to get x squared, x to the 4th, x to the 6th. Could you integrate the right-hand side? Yes, easily. If I wanted to integrate x inverse tangent of x, then I would make that the integral of x plus x to the 4th over 3 plus x to the 6th over 5, etc., etc. And I can do that, can't I? Can't I do this? Find those antiderivatives easily? It's just the power rule. I don't know how to integrate x inverse tangent of x. I don't even know if it's doable. I'd have to probably do some sort of use substitution. That's techniques of integration, something you do in college. Okay, so I want to write that as a power series, yeah.
Is the thing on Wednesday
Little.
How did you write the other?
As a what? We don't ask you to do that. Okay, what's all that about? Oh, it's not that hard. So I want to do this as a power series. By the way, this is geometric. So what is this really going to do? It's 1, because all I know is this. What is that, Matt? What is this as a series? 1 plus x squared plus x cubed, x to the n, right? So how can I get this to be in that form? 1 minus negative x to the 7th. So I'm going to put in, if you did the homework, then you know what I'm talking about. In place of x over there, I'm going to put in minus x to the 7th. And then I'm going to actually integrate this thing. So it's 1. And in place of x, I'm going to put in minus x to the 7th plus, and then it's minus x to the 7th squared. I'll write it out. Then it's plus minus x to the 7th to the 3rd minus x to the 7th to the n. And I can't find the c because I don't have anything on the other side. I don't know what it is. It's not an inverse tangent. I don't know what it is. So I'm going to have to leave the c there. So this integral is, I'm going to simplify this. What's this going to be? No, x to the 14th. What's the next one going to be? Minus x to the 21st. It is. We'll talk about what x can be. Then this is minus 1 to the n. Just use your properties of exponents. And it's x to the 7n. And that's the answer to this. To A. Oh yeah, I forgot to integrate it. Thank you. Okay, let's integrate it. But you don't have to write it in sigma. I'm sure that the book will have written it in sigma. I don't care. Right. Okay, guys, can you integrate 1 over 1 plus x to the 7th? Who's got a CAS calculator? You can try it. I don't think you can do it. It's a technique to integrate things you can't integrate if you can express it as a power series. So let's integrate this. And so you can work with these infinite series. They're not that bad. What's this going to give you? David? We're integrating. Don't tell them. Plus x to the what? 15 over 15 minus x to the 22nd over 22. They will ask you to do the nth term. So it's x to the 7n. What do you do with it? Plus 1. You know this. 7n plus 1. Yes, I missed my n. Okay, I can't integrate the original one.
You put it through you don't need to, dude.
You can try it.
What?
You can try it.
Why would you? Oh,
what are you going to you substitute it for? I don't have the derivative of x to the 7 x to the 7. Plus c, and I can't find out what c is. Because before I knew what the function was, like it was an inverse tangent or something, I don't know what this is. Okay, we're going to turn the page. Ready? I'm going to turn the page. Oh, no, we just have a little bit more left to do. So we are going to... Okay, there it is. That's... Now we're going to have C on this one? No, and unless I ungroup it, I can't erase it. Huh? We can't find C because before we knew that was an inverse tangent or something. We don't know what the left-hand side is. So I'm going to get the C out because this is the fundamental theorem. And what are we going to do? We are going to evaluate this at 0, and that's a 0.5, 1/2. When does this converge? What has to be true about the amplified x? Less than 1. It's geometric. Okay, so we put the 1/2 in there. So it's, and this often happens on the free response part of the exam. Okay, this is a free response questions probably. Minus, 1/8 times 1/2 to the 8th. Are we okay with that, what I just did? Algebraically, is that okay? It's 1/2 to the 8th, but it's divided by 8, so the 2 and the 8 are in the denominators. Then this is going to be plus 1/15. We're going to need a calculator in a second. 1/2 to the what? 15. Sometimes they give you this, you say, oh, it's just a geometric series, I can find this out. But this isn't. This is not a geometric series up here anymore, is it? And it's minus 1 over 22, 1/2 to the 22, etc. Oh, I suppose I can put it in this. Negative 1 to the n, 1/2 to the 7n plus 1 over 7n plus 1. Yeah.
So can you figure out those?
Sure. We're going to. We're going to. We're going to do C, using the alternating series estimation theorem. It can happen on this kind of a series. It can happen on a Taylor series. Doesn't matter. And then I have to subtract 0 and placed in there. But what's that going to be? 0. So that's the infinite series for that, which I could have just used my calculator and integrated it. Maybe we will. Yeah, that's all you can do until you get to C. Using the alternating series estimation theorem, which I've probably forgotten, I want the error for this. Oh, it's not going to let me do that. Okay. Okay, you guys ready? You remember that your error, I want this 10, I need a calculator though, 10 to the negative 7th. That's what? 1 over 1 followed by how many zeros? So it's 10 million. Okay, so I want, or I can do this. Is that right? Okay, so I just have to evaluate this. So I need a calculator. Who's got one? Justin, it's Monday. So it's 1/2. This is going to converge very quickly, though, because it's minus 1/8, and it's 1/2 to the 8th. 2 to the 8th, 2 to the 4th is 16. 16 times 1 over 256. Am I right? Yes, it is. Do you have a cast? Oh. So what is that? Oh, yeah. I need you guys to calculate that out. Yeah, we have to find the actual number because we want to be less than this number. So guess what? You need 7 zeros. And then you're done. But it doesn't take very long. Plus, well, let's actually do it, and then let's integrate on the calculator and see if we're right. Well, that could be, so he did these. 0.499 what?
5.
Okay, now we're going to do 1 over 15, and it's 1/2 to the 15th, and I don't know what 2 to the 15th is. So it's 1 divided by 15 times 2 to the 15th. Make sure you use parentheses. You say, oh, it's a calculator, so it's easy. Not necessarily. What is that one? Yeah, I need it as a decimal.
3.5. That's like just that.
This? Is that it? She won't give me a decimal. 3.05 times 10 to the negative 5th. No ease. That means I count 5 to the left.
Yeah, that's not what we got.
What did you guys get?
Point 0, 0, 0, 0, 0.
How many zeros?
5, 0.
5, what?
2, 0, 3, 4. 3, 5.
Okay, doesn't matter. Still not small enough. We need one, well,
It's gonna be one more.
well, let's find out what the next term is. It's minus 1 over 22 times 1 over 2 to the 22 Remember, the error is less than the first discarded term, so I don't know what that is. So you have to use calculator. Imagine the day and age when I took this, we didn't have calculators. I don't know what we did. We used slide rules. You can give me scientific notation first. -8, which is 6, 7. Okay, all the rest of the errors is smaller than that. That's what the alternating estimation theorem says. So, you always want to add these up. This plus that, and we don't even need this because it converts really quickly. Yes, you needed 7 zeros, didn't we?
Don't some of you have to subtract.
We only need 6 zeros.
But I think we did that one.
This is a minus.
I got 0.499.
Okay, what do we have? You take this plus that minus that. Point. Notice this is not going to affect the first 3 places, is it? Is it? No. So what is this plus that? I don't need a calculator. Okay, I've got this lined up wrong. 5 and 2 is 7. 1, 3. Oh, no, those are zeros. Never mind. What am I doing? So it's 5, 1, 3, 7, 3, 4. And if I add this in there, or subtract it, 6, 7, 1, 0, 8, 3, all of these first digits, I mean, it's worth doing to understand what's going on. And this is going to have to, I don't even have to borrow. So it's 2, 4, 8, 3. There it is. There's my error. So you guys, should we integrate that thing? Do you want to do it, or do you want me to do it? It's right there. 0.49. How many places did I do? 1, 2. I only did 3. It converges so quickly. The fourth one is so small, it doesn't affect the first 7 places. But why did I what? What for? I don't even see a 2483. Oh, because I only have to be correct to the 7. So let's find out. Let's do it on a calculator. And then the rest of the time is to work. All right, okay. So we want to integrate. Okay. So in y1, I'm going to put in my function because I know I'll mess it up. It's 1 divided by parentheses 1 plus x to the 7th, right? Did I do that right? Matt, did I do that right? Yes. Because I've got the fancy upgraded calculator. So we're going to go on. Now, I'm not, you know where it is. It's under Math 9. But I probably have it here. If you have the pretty print, it's right here. The integral 4. And we want to do 0 to a half. It will not converge if that value is higher than a half. And then we want my y1. And I can get my y1 here. So if you don't have this, you should put it on your calculator. And I need a dx. If you want to bring it to CAS, we can find out what the exact answer is, if it's doable. Did I do it? Did I do it right? That's what you would do if you can't integrate. Now, in this case, I can use the fundamental theorem of calculus, so my numerical derivative will work. So it's okay. So for those of you who are interested in the CAS, this will take a second. Huh? And you type something wrong. Let me stop. Oops, I don't want that.